Hey scientists, it's Mrs. Aquilia. I'm here in my kitchen science lab, and it's time for science experiment of the week number 8. So, I want to show you something very interesting. This is not what's interesting. This is just a container full of water, a clear container full of water. I want to show you what happens when I take a regular pencil and I put it in that water. Do you see how it looks when we look at it through the water? Like I'm looking at the pencil through the water, and then the water stops here, and then we're looking at it in the air, right? Do you see how it looks bent? Like it's in two separate pieces. It actually looks fatter in the water, right? And it looks like it's in one piece here, and then once it comes out of the water, it looks a little bit different. It looks skinnier, and it's like in a separate piece, right? We know it's not in a separate piece. That's just the way it looks. Well, that's because of something called refraction. And refraction means that light bends as it goes through water. And the way that our eyes see light differently in the water, and when I say see light, I mean the light and the objects and everything that might be in water, it looks different in water than it does in air. Okay? And we're only able to see because of the light, and because the light is bending, it looks like the actual pencil is bending when we know that it's not, right? Okay, so there's some kind of funky things that happen when you put light and water together, all right? When we look at things through water, the way that our eyes see the light is really kind of funky. And I want to show you something amazing, okay? Now I have here a little red arrow that I drew on a piece of paper. And if I hold the arrow close to the camera, I see that it's pointing to the right. And as I move it back, it looks like it's a little smaller because I'm moving it further away, but nothing is changing about this arrow. I'm looking at it right through the air, and nothing is changing. It's still pointing to the right. It's not doing anything weird. I want you to see what happens now when we instead do that, looking at it through the water. So I'm kind of scooching down, and I'm going to look at that arrow through the water, and I'm going to do the same thing. I'm going to move it back towards like the back of my counter, all right? Already that arrow looks kind of funky, right? So we see that the arrow is pointing to the right. It's pointing to the right. Watch what happens when I move it back. First of all, look at how funky that is. It looks like there's like 3 arrows. And as I continue to move it back, look at what happened. It got really long, and now it's pointing to the left. Let me show you again. I move it closer so that it's right up against the back of the container. And now when I put it further back towards the back of my counter, look at what is happening. It's long and it's pointing to the left. Right, left, right, left. You can see that I'm not doing anything with the paper other than moving it forward and backward. How crazy is that? Darla, how crazy is that? Well, that is something called optical inversion. An optical inversion is something that happens because of that bending of light. Optical is anything having to do with our eyeballs. When we see something, it's called optical. An inversion is when we change the order of something, when we kind of like flip it. Okay? So now I'm going to show you something else really cool. Well, it's actually kind of the same thing, but it's different and better. Okay, so what I did was I wrote my name, Mrs. Aquilia, on a piece of paper, and I'm going to do the same thing. I'm going to hold it, have it right up against the back of this container, and because we're looking at it through water, we're going to see that optical inversion. That means that it's going to appear to our eye that it is flipping, and it's going to do that because of refraction. Okay, so check this out. So I hold it here and I move it back. Can you see that it's backwards now? Do you see that it's backwards now? It's almost like I would see it in a mirror. Well, it's exactly as I would see it in a mirror. The right way and backwards. So I thought it would be really cool to try to write it backwards so that if I start out with it backwards and then I move the paper back and it optically inverts, that would mean that I would see it forwards, right? So what I did was I wrote my name backwards, which kind of took a little while because it wasn't so easy to do. So let's see now what happens when I take my backwards name and we're looking at it through the water, and now I'm going to move it. Wait. Look at that. My name is not backwards anymore. I mean, it is if I raise the phone and now we're looking at it just through the regular air. But when I look at it through the water, because the light is bending, you see how that looks like I wrote it the right way, but yet I didn't. That's pretty cool, right? So boys and girls, I want you to try this at home. It's really fun to do. It's really easy to do. All you need is a clear container of water, and you can draw things and you can write things and see how they go through that optical inversion, how they look different to your eyeball through water because the light is bending. Okay, but I want you to remember something. Sometimes things look like magic, but they're not. You know what they are, even if they look like magic? They are science!